Hello students, welcome to Diksha Karnataka YouTube channel. Abhyas KCET 2024 mock test 8 has been released, right? So in this video, I'm going to discuss the solution of mock test 8, question number 121 to 150. If you haven't downloaded the question paper, please join the WhatsApp channel using the link which is given in the description box. Okay, yeah, let us start. Question number 121. Illuminance of surface is measured in lux. Okay, direct question, right? So option C is the correct answer. Okay, direct question from the first chapter, units and measurement. Yeah. Second question, 122. Question number 122. Speedometer of a car measures. Here, the speedometer of a car measures instantaneous speed. Okay, instantaneous speed. So option C is the correct answer. Okay. Next question. This question came from kinematics. Okay. Next question, 123. Water is used as a coolant because here water is used as a coolant because it has high specific heat. High specific heat. That's why we use water as a coolant in automobile radiators, right? Isn't it? So the correct option is C. Okay. Till now it's direct questions, right? Yeah. Question number 124. Which of the following system of units is not based on units of mass, length and time alone? SI unit, right? Isn't it? Why? SI unit has 7 fundamental units, isn't it? So option A is the correct answer. Here MKS, CGS and FPS, these three have only mass, length and time. Okay. Here SI unit has 7 fundamental units. So option A is the correct answer. Yeah. Question number 125. A vessel has 6 gram of oxygen at pressure P and temperature 400 Kelvin. Here P1 equal to P, okay, M1 equal to 6 gram and T1 equal to 400 Kelvin. A small hole is made in it, that is made in a vessel, so that oxygen leaks out. How much oxygen leaks out if the final pressure is P/2 and temperature 300 Kelvin? Okay, so here we have to use ideal gas equation to find how much oxygen leaks out from the vessel, right? Okay, what is the ideal gas equation? Ideal gas equation is PV equal to nRT, right? What is P? P is pressure, V is volume, N is number of moles, R is universal gas constant, T is temperature, right? So now PV is equal to N is number of moles, right? Number of moles is mass of the given gas divided by molar mass of that gas. Now M divided by capital M into R into T, right? PV equal to small m by capital M into R into T, right? So pressure P is directly proportional to small m into T, right? V, capital M and R are constant, isn't it? Now here P2 divided by P1 is equal to M2 divided by M1 into T2 by T1, right? So what is T2? T2 is 300 Kelvin. P2 is P/2, right? So now we need to find the value of M2, right? Now M2 is equal to P2 into T1 divided by P1 into T2 into M1, right? Now M2 is equal to P2 is P/2, right? T1 is 400 Kelvin, right? 400 divided by P1 is P into T2. T2 is 300 Kelvin into M1. M1 is 6 gram, right? Now 100 will get cancelled, right? 2 2s are 4, right? So 3 2s are 6, isn't it? P will also get cancelled. Finally M2 is equal to 4 gram. So the correct option is B. Okay, yeah. Next question, question number 126. The isothermal diagram of a gas at three different temperatures, T1, T2, T3 is shown in the given figure. Okay, then, so we need to find the order of the temperature. Okay, so we know that in PV graph for isothermal process, as the curve moves away from the origin, the temperature increases, right? Isn't it? So as the curve moves away from the origin, the temperature gets higher, isn't it? So here T1 is greater than T2 is greater than T3. This is the order. So the correct option is C. Okay, direct question, right, from the thermodynamics. Yeah. Next question, question number 127. An ice block having two similar metallic pieces is floating in water in a vessel as shown in the figure. Okay, so this is the given figure. Okay, so this is ice. Okay, these black things here, this one and this one, is metallic pieces. Okay, MP is metallic pieces. After some time, the ice melts completely then. Okay, so we don't need to look at the option. Okay, let's see what happens. So when ice is floating on the water, so there will be a volume displaced, right? So water displaced, right, isn't it? Volume of the water displaced is Vd. Okay, volume of the water displaced is Vd. So how much volume of the water displaced? Here volume of the displaced water is equal to volume of the ice which is submerged under the water, right? Volume of the displaced water is equal to volume of the ice which is submerged under the water, right? See here, volume of the metallic pieces is lesser compared to the volume of ice, isn't it? From the diagram only we can say volume of the metallic pieces is lesser than volume of the ice, right? Isn't it? When ice completely melts, what happens? Here these two metallic pieces sinks down, right? These two metallic pieces sink down, isn't it? Right? These two metallic pieces sink down. So then what happens? The level of water falls, right? Level of water falls because the volume of the displaced water is lesser, right? So that's why the level of water falls, isn't it? So let's look at the option now. The water level rises in the vessel. Wrong. The water level falls in the vessel. Correct, right? The water level falls in the vessel. Option C says the water level does not change in the vessel. Wrong. Option D says the water level may rise or fall depending upon the ratio of the masses of the ice and metal. Wrong, right? Option D is also wrong. So the correct option is B. Yeah. Next question. Question number 128. Which of the following graphs represent stress strain variation for elastomers? So what is elastomers? Elastomers is a polymer, okay? Polymer which can stretch, okay? Isn't it? So it's a kind of polymer, so we can stretch, okay? Best example, rubber. It's a elastomer, okay? Here the graph of stress versus strain for elastomer like this, okay? So the correct option is C. Okay, direct question. Next, 129. The center of mass of a body lies always at the geometrical center. Wrong. Center of mass of a body may lie within the body or outside the body. Okay, not exactly sphere. Okay, so here this is the body. Okay, center of mass of the body may lie within the body, okay, or outside the body. Understood? So option B says lies always inside the body. Wrong. It may lies outside the body. Option C says lies always outside the body. Wrong. Option D says may lie within or outside the body. Yeah, correct. Option D is the correct answer. Question number 130. When a disk rotates with uniform angular velocity, which of the following is not true? Okay. So when disk rotates, uniform angular velocity, right? Here, the sense of rotation remains same, correct, right? The sense of rotation remains same. The orientation of the axis of the rotation remains same, correct, right? Suppose this is the uh, body, okay, it is rotating with the angular velocity, uniform angular velocity omega about the this axis, or uh, this body can rotate, or like, here this is ring, right, isn't it? So this ring is rotating with the angular velocity omega about the axis which is passing through its center, right? Now this is the another orientation. Here this ring is rotating with uniform angular velocity omega about the axis which is passing through the diameter of this ring, right? So still the uniform, here the angular velocity is same, right, isn't it? So the orientation of the axis of rotation remains same. So option B is also true, the correct statement, right? Here we need to find the wrong statement or false statement. The speed of the rotation is non-zero, correct, and remains same. Again, this statement is also correct, right? Option C is wrong. A, B, C are wrong. The remaining option is D. Okay, let's see. The angular acceleration is non-zero. Wrong. Angular acceleration is 0, right? Because angular velocity is constant, right? Alpha is d omega by dt, right? Omega is constant, so angular acceleration will be 0. So the third option, sorry, the last option, option D, is the correct answer, right? Why? Because the statement is wrong. Here we need to find the wrong statement. Okay. Next question, question number 131. Figure shows the position time graph of one-dimensional motion of a body mass 500 gram. What is the time interval between two consecutive impulses received by the body? Okay, so what is the meaning of impulse? Impulse J is equal to, here impulse J is equal to change in momentum, right? Change in momentum, isn't it? So let's see the graph. Oh, okay, let's look at the graph. Here at time t equal to 2 second, okay, at time t equal to 2 second, here the direction of the body changes, right, isn't it? Right, the direction of the body changes. Initially it is moving along positive x direction, okay, or positive x axis, we can say. Sorry, it is moving along positive direction, not positive x axis and all, okay. It is moving along positive x direction. At t equal to 2 seconds, it reverses its direction, that is negative direction, right, isn't it? Again, at t equal to 4 second, its direction changes, right? At t equal to 6 second, its direction changes, right? So therefore here every 2 seconds its direction changes, isn't it? So impulse received by the body, here the time interval between the two consecutive impulses received by the body is 2 seconds, right? So option A is the correct answer. Okay, yeah. Next question, question number 132. The coefficient of static friction between the box and the train's floor is 0.2, that is mu s equal to 0.2. The maximum acceleration of the train in which a box lying on its floor will remain stationary is, okay, so this is the train, okay, train is moving with acceleration a, the box is lying on the train's floor, okay. So when train moves with acceleration a, this box experiences pseudo force, right? In which direction? Opposite to the direction of the train's direction, right? So what is the pseudo force acting on this block? The pseudo force acting on this block is mass of the block into acceleration of the train, right? M into A, isn't it? Now we need to find maximum acceleration of the train in which box lying on its floor will remain stationary, okay. Now here the maximum acceleration, right, we need to find. So that is ma, the pseudo force must be equal to the maximum static friction, right? So in which direction static friction is acting on? Opposite to the direction of the pseudo force, right? This way, Fs, isn't it? Fs is here, the maximum static friction is mu s into n, right? M into A equal to mu s into n. I am writing maximum static friction, okay, not just static friction, maximum static friction, that is limiting friction, right? Okay, so now A is equal to mu s into n divided by m. So what is n? N is normal reaction, right? So this is the normal reaction, and the gravitational force acting on this block is mg, right? So n equal to mg. Is there any vertical motion? No, right? So n equal to mg. So A equal to mu s into mg divided by m. M will get cancelled. So A is equal to mu s into g. Okay. So g is 10 meter per second square. A equal to mu s is 0.2. 0.2 into 10 is 2. So 2 meter per second square. This is the maximum acceleration. Okay, maximum acceleration of the train, in which box laying on its floor will remain stationary. Okay, so option A is the correct answer. Understood? Yeah. Next question. Question number 133. A person of mass 50 kg stands on a weighing scale on a lift. Here, this is the lift. Here, the person is standing on a weighing scale, okay, on a lift. If the lift is accelerating upward with a uniform acceleration of 9 meter per second square, A equal to 9 meter per second square, what would be the reading of the weighing scale? Okay, here we need to find reading of the weighing scale. Here, the normal reaction acting on this man is N, right? And the gravitational force is mg, right? The gravitational force is mg. Here we can solve this problem, okay, in ground frame of reference or lift frame of reference, or acceleration frame of reference, okay, this frame of reference. Now here let us draw the free body diagram. Okay, so this is my frame of reference, okay, y and x, okay. Okay, then isolate the body. Here the body is a man, right? Man, okay. Normal reaction is N and mg, right? Normal reaction is N and mg. And here the lift is moving in upward direction A, right? Lift is moving with upward direction A, isn't it? Yeah. Now apply Newton's second law of motion. Now Newton's second law of motion, summation of fx equal to m into ax and summation of fy is equal to m into ay. See, I am doing all these things because you will learn how to solve this Newton's laws of motion. Okay, you will, here I am solving all these things, okay, here, but in the exam you won't get much time, okay, to solve all these things. Okay, you have to practice a lot. Okay, so summation of fx equal to m into ax. Is there any horizontal force acting on this man? No, right? So it's 0, right? Summation of fy into m into ay. Summation of fy into m into ay, that is all the vertical forces acting on a man is equal to m into ay, okay, or net vertical force acting on a man, that is n minus mg, right, which is equal to m into a, right? N minus mg equal to m into a. Now n equal to m into g plus a, right? Now n is equal to m into g. G is 10 meter per second square, a is 9 meter per second square. Okay, so now here n is equal to m is 50 kg, okay, 50 into g is 10 and a is 9, so this will be 19, okay. So n equal to 19 zeros are 0, 19 into 5. Here 19 into 5, right? So this will be 95. Okay, n equal to 950 Newton. Okay, n equal to 950 Newton. So the reading on a scale is 95 kg, right? Reading on a scale is 95 kg. So option C is the correct answer. Divide 950 by 10. Okay, so the reading on a scale will be 95 kg. Next question, question number 134. A hospital uses an ultrasonic scanner to locate tumors in a tissue. The operating frequency of the scanner is 3.2 megahertz. Okay, here f equal to 3.2 megahertz, that is 10 to the power 6 hertz. The speed of the sound in a tissue is 1.6 kilometer per second. Okay, so v equal to 1.6 kilometer per second, that is v is equal to 1.6 into 10 to the power 3 meter per second. The wavelength of the sound in the tissue is, okay, we need to find the value of lambda. Okay, we know that velocity of the wave v equal to lambda into f, right? So lambda equal to velocity of the wave divided by f, right? Now substitute the values. Lambda equal to v is 1.6 into 10 to the power 3 divided by f is 3.2 into 10 to the power 6. Okay, so 1.6 by 3.2 is 1 by 2, right? 1 by 2 is 0.5, right? So lambda is equal to 0.5 into 10 to the power minus 3 meter. So lambda equal to 0.5 millimeter. So the correct option is B. Okay, yeah. Next question, question number 135. The time period of an artificial satellite in a circular orbit of radius r is 2 days. Here r1 equal to r, okay, t1 equal to 2 days, and its orbital velocity v0. If time period of another satellite in a circular orbit is 16 days, okay, t2 equal to 16 days, then its radius of orbit is 4r and orbital velocity is v0. Okay, here we need to find radius of the orbit and orbital velocity. Okay, so let's apply Kepler's law. Okay, Kepler's third law. So what is the Kepler's third law? Kepler's third law says t square is directly proportional to r cube, right? So t is the time period of the satellite, right? R is the radius of the circular orbit, right? So this is the Kepler's third law. Now here we need to find the radius of the second orbit, right? Isn't it? So r2 divided by r1 is equal to t2 divided by t1 to the power 2 by 3, right? Isn't it? So r2 divided by r1 is r equal to t2 is 16, right? t1 is 2. So 16 by 2 is 8. So 8 to the power 2 by 3, right? So 8 to the power 2 by 3 is 4, right? Which is equal to 4. So r2 is equal to 4r. So here C and D both are eliminated, right? So they are saying its orbit radius of the orbit is 2r, wrong, right? So we need to find the correct option between A and B. Okay, so next we have to find orbital velocity, right? How to find the orbital velocity? We know that orbital velocity v0, okay, is equal to root of gm divided by r, right? Isn't it? So from this I can conclude that orbital velocity v0 is directly proportional to 1 by root r or inversely proportional to root r, right? Now v02 divided by v01, v01 is orbital velocity of the first artificial satellite, okay, which is equal to root of r2, sorry, root of r1 by r2, right? Root of r1 divided by r2, root of r1 by r2, okay. R2 is 4r, right? R1 is r. Now v02 is equal to V01 is V0, right? So V0 divided by 2. So orbital velocity of the second satellite is V0 by 2. Okay, so first option is wrong, so the correct option is B. Okay, yeah. Next question, question number 136. Which of the following statements is correct regarding the universal gravitational constant G? G has same value in all systems of unit. Wrong, right? So G has different value for different system of units, right? So for SI unit, it's 6.67 into 10 to the power minus 11. What is the SI unit of the G? SI unit of the G is Newton meter square per kg square. Newton meter square per kg square, right? So for CGS, it is different, right? Isn't it? So what is the value of G in CGS? The value of G in CGS is 6.67 into 10 to the power minus 8, 10 to the power minus 8 dyne centimeter square per gram square, right? Dyne centimeter square per gram square, isn't it? So the value of G is different for different system of units, right? So option A is wrong. Option B, the value of G is same everywhere in the universe. Correct. The value of G is same everywhere in the universe. Option C, the value of G was first experimentally determined by Johannes Kepler. Wrong. So it is first experimentally determined by Cavendish. Okay, Cavendish. Okay, so in Cambridge University, they have the separate laboratory. Okay, they named his name only. So the Cavendish, Henry Cavendish. Okay, Henry Cavendish. Okay, and then option D, G is a vector quantity. Wrong, it's a scalar quantity, right? Yeah. I hope everybody understood. Yeah, next question. Question number 137. The number of ways one can arrange three identical capacitors to obtain distinct effective capacitance is. Okay, so we have three capacitors, right? Isn't it? So we have to find the number of ways one can arrange three identical capacitors to obtain distinct effective capacitance, right? So the first way, all three are in series, right? Here we will get C equivalent is equal to here 1 by C1 plus 1 by C2 plus 1 by C3, right? And then all three are in parallel, right? Here C equivalent is equal to here the number of ways one can arrange three identical capacitors. So C, right? So this will be C by 3, right? So this will be 3C, C plus C plus C, right? So which is equal to 3C, right? And then another way, two are in series, okay, and one is in parallel with these two, right? So 1 by 2C, right? So this will be C by 2, okay. Here this will be C by 2, right? C by 2 plus C, that is 3C by 2, C equivalent. And the last way, here the one capacitor is in series with two capacitor, these two capacitors are in parallel, right? So that is here C equivalent, okay, C equivalent is equal to here 1 by C plus 1 by 2C, right? 1 by C plus 1 by 2C. So C equivalent, this is 1 by C equivalent, okay. C equivalent is equal to here 2C by 3, okay. So there are four ways, okay. So option C is the correct answer. Next question, question number 138. The number of electrons present in -1 coulomb of charge, okay. So from the quantization of charge, the total charge is equal to integral multiple of E, right? E is the charge, the value of charge. What is the value of charge? 1.6 into 10 to the power minus 19 coulomb. So for electron, it is minus 1.6 into 10 to the power minus 19 coulomb, right? Now what is the total charge? Total charge is minus 1 coulomb, right? Which is equal to N into E is minus 1.6 into 10 to the power minus 19 coulomb. That is charge of the electron, right? Now N is equal to minus will get cancelled. 1 divided by 1.6 into 10 to the power 19, right? So 1 divided by 1.6 is 6.25. 6.25 into 10 to the power 19. Okay. So here the close, okay, look at the option C. Here they have given 6, right? Isn't it? 6.6 is closest to 6.25, right? So option C is the correct answer. Question number 139. A particle of mass 10 to the power minus 3 kg and charge 5 microcoulomb, here Q equal to 5 microcoulomb, M equal to 10 to the power minus 3 kg, is thrown at a speed of 20 meter per second. That is, initial speed of the particle is 20 meter per second against a uniform electric field of strength 2 into 10 to the power 5 Newton per coulomb. The distance traveled by the particle before coming to rest, that is, final velocity of the particle is 0, right? So here I am going to use third equation of motion. Okay, the third equation of motion is v square equal to u square plus 2as. Okay, the final velocity is 0, right? 0 equal to, okay, I am going to write here 2a dash s. Okay, I will tell why I used 2a dash. Here a dash is retardation, not acceleration. Okay, so a dash equal to minus a, right? So 0 equal to u square minus 2a s, right? Here a dash is minus a. Okay, so it's a retardation, not acceleration, because the velocity of the electron, sorry, the charged particle decreases, right, when it moves against the electric field. Now u square equal to 2as, we need to find the value of s, right, the distance traveled by the charged particle before coming to rest. S equal to u square divided by 2a, right? So we know the value of u, we have to find the value of a, that is retardation, right? Here we know that F equal to ma, right? Newton's second law of motion, right? So in this case F is electric force, right? Electric force experienced by the charged particle. So what is the electric force experienced by the charged particle? It's Q into E. Q into E equal to M into A. Here A is retardation, okay? Retardation or decreasing acceleration. Now A equal to QE divided by M, right? A equal to Q into E divided by M. Now substitute A to this equation. S equal to U square divided by 2 QE by M. Okay. So now S equal to U square is 20 squared. 20 squared is 400 divided by 2 into here Q is 5 into 10 to the power minus 6. E is 2 into 10 to the power 5. 2 into 10 to the power 5 divided by 10 to the power minus 3. Okay, so now here 2 into 2, 4, right? 2 into 2, 4. So this will be 100. Okay, so 100 divided by 5 is 20, right? So 20 into 10 to the power minus 3 divided by 10 to the power minus 1. So this is S, right? So S equal to, here 20 into 10 to the power minus 3 is 2 into 10 to the power minus 2, right? So 2 into 10 to the power minus 2 divided by 10 to the power minus 1, that is 10 to the power minus 1 only. So 2 into 10 to the power minus 1 meter, that is S equal to 0.2 meter. So the correct option is B. Okay, yeah. Next question, question number 140. A circular plane sheet of radius 10 cm is placed in a uniform electric field of 5 into 10 to the power 5 Newton per coulomb, making an angle of 60 degree with the field. Okay, so here this is the sheet. Okay, this is the sheet, or I can right? Or I can draw here like this. This is the sheet, okay? Here the value of electric field is given. So the plane sheet is making an angle 60 degree with the electric field. Making an angle 60 degree, okay? 60 degree with the electric field. 60 degree with the electric field. The electric flux through the sheet is, okay, here electric flux phi is equal to EA cos theta, right? E is electric field vector, A is area vector, okay, theta is angle between E and A, okay. So what is the direction of A? The direction of A is perpendicular to the plane of the circular sheet, right? Circular plane sheet. So this is the direction of the A, right? Isn't it? Now I can write phi as A into E cos theta also. A into E cos theta also, right? I can write phi as E into A into E cos theta also, right? So what is the meaning of E into A cos theta or A into E cos theta? Here E into A cos theta means angle, sorry, here the component of A along E, okay? A into E cos theta means component of E along A. So this is E, okay, the component of E along A. So what is the remaining angle? Remaining angle is 30 degree, okay. The angle between E and A is 30 degree, right? Now phi is equal to E. E is 5 into 10 to the power 5 into A. A is pi into r square. R square is 10 to the power minus 2 meter square into cos 30 degree, right? Cos 30 degree. So now solve this, you will get electric flux as 1.36 into 10 to the power 4 Newton meter square per coulomb, okay? So the correct option is B. Yeah, next question, question number 141. A parallel plate capacitor is charged and then isolated. The effect of increasing the plate separation on charge, potential and capacitance respectively are. So parallel plate capacitor separated by distance d, separation between the two plates is d. Now it is charged and then isolated. The charge remains same, right? It is constant, okay? So the charge is constant, okay? Let's see capacitance. Capacitance C equal to epsilon naught A divided by D for parallel plate capacitor, right? When separation increases, capacitance decreases, right? So C decreases, capacitance decreases. Let's see for potential. Here the potential V equal to E into D, right? E is electric field between the capacitor. When D increases, what happens? Potential will also be increases, right? So V equal to, sorry, potential will be increases, or you can solve like this. Here V equal to Q divided by C. When C decreases, V will be increases, okay? So V increases, potential increases. So the correct answer is charge is constant, potential increases, capacitance decreases. So option D is the correct answer, okay? Yeah, question number 142. A parallel plate capacitor has a uniform electric field E in the space between the plates. If the distance between the plates is D and the area of each plate is A, the energy stored in the capacitor is. Energy stored in the capacitor is half C into V square. We know that C equal to epsilon naught A by D. V equal to E into D. E is electric field, okay, D is separation between the capacitor, A is area of the parallel plate, okay, area of the plate. Now energy stored in the capacitor U equal to half into C is epsilon naught A divided by D into V square, that is E square into D square. Here D will get cancelled, so U is equal to half epsilon naught E square into A into D, okay? So this is the energy stored in the capacitor, so option C is the correct answer, okay? Yeah, next question, question number 143. The electrical resistance of a conductor depends upon, okay, let's check each option. Size of the conductor, yeah, correct, right? It depends upon the size of the conductor, okay? The length of the conductor, right? Yeah, next one, the temperature of the conductor, correct? electrical resistance depends upon the temperature of the conductor. Here, temperature dependence of resistance R equal to R naught into 1 plus alpha into delta T, right? Alpha is coefficient of resistance, okay, and then temperature coefficient of resistance, delta T is change in temperature, right? R naught is the resistance of the conductor at a reference temperature, right? R is the resistance of the conductor at temperature T, okay. So it depends on the temperature of the conductor. Geometry of the conductor, correct, right? So it depends on the area of the conductor, right? Area of cross section of the conductor. So option C is also correct. Option D, all of the above, correct, right? So the correct option is D, all of the above. Next question, question number 144. Figure A and figure B both are showing the variation of resistivity rho with temperature T for some materials. Identify the type of these materials. Okay, so two graphs are given, right? So first graph of resistivity versus temperature, right? So this graph is for conductor, okay, this graph is for conductor, and second graph is for semiconductor, okay, semiconductor. So the correct option is A, okay. Next question, question number 145. If n, e, tau and m are representing electron density, charge, relaxation time and mass of an electron respectively, then the resistance of the wire L and cross-sectional area A is given by. So resistance R equal to rho L by A, okay. So from the drift velocity you can derive this expression, okay. So I will directly write here. So R equal to m into L divided by n e square A square into tau. Tau is the relaxation time, okay. A is the area of cross section, E is charge of the charged particle, okay, charge of the electron, L is length of the conductor, m is mass of the electron, okay, n is the number of electron, okay. So the correct option is A. Next question, question number 146. In the given circuit that potential at point B is 0, the potential at points A and D will be, okay. So let us find the potential at point A, okay. So VA minus VB is equal to, here this is the direction of the current, right? So this is the direction of the loop also, okay, or your direction or my direction. I am moving in this way also, okay. So this will be 2 divided by, the current is 2 ampere, R is 2 ohm, so I into R, okay, I into R is 4 voltage, right? So in the question they have given VB is 0, right? So VA, that is potential at A, is equal to 4 volt, right? Potential at A is equal to 4 volt. So we need to find potential at D. Here the point D connected to the higher potential, right? That is 3 volt. Higher here the positive terminal, right? Or higher potential, right? So potential at point D, VD is equal to 3 volt, okay, 3 volt. So the correct option is T, okay. Yeah, question number 147. To minimize the power loss in the transmission cables connecting the power stations to homes and factories, the transmission cables carry current, okay, at a very low voltage. So this is wrong. Why? Here the power transmission or power dissipated in the transmission cable is inversely proportional to square of the voltage at which current passing through the transmission cable, right? So to minimize the power loss, we need to increase the voltage, right? We need to send the current at a very high voltage, right? So the correct option is B, okay. Next question, question number 148. When a piece of aluminum wire of finite length is drawn through a series of dies to reduce its diameter to half its original value, the resistance will becomes, okay. A piece of aluminum wire finite length is drawn through a series of dies to reduce its diameter to half its original value, okay. D2 is equal to D1 divided by 2, Okay, d2 is equal to d1 divided by 2. We need to find the resistance, right? So we know that resistance R is inversely proportional to square of the area of cross section of the wire, right? A is directly proportional to D, right? So R is directly proportional to 1 by D to the power 4, right? Now R2 divided by R1 is equal to R2 by R1 is equal to 1 by D2 to the power 4 divided by 1 by D1 to the power 4. Now R2 divided by R1 is equal to D1 to the power 4 divided by D2 to the power 4, that is D1 to the power 4 divided by 16, right? 2 to the power 4 is 16, right? Now R2 equal to, here 1 by 1 by 16 is 16, R1 times 16, right? So its resistance will become 16 times. So option D is the correct answer. Okay. Question number 149. The figure shows stopping potential V0 and frequency nu for two different metallic surfaces A and B. The work function of A as compared to that of B. Okay, work function of A is lesser than work function of B. Why? Because the threshold frequency for A is lesser than threshold frequency for B. So threshold frequency, work function depends on the threshold frequency. So threshold frequency of A is lesser than threshold frequency of B. So therefore, work function of A is lesser than work function of B. So work function of A is less compared to that of B. Okay. Question number 150. A light of wavelength 0.6 micrometer. Okay, so this is micrometer. 0.6 micrometer, that is 0.6 into 10 to the power minus 6 meter, from a sodium lamp falls on a photocell and causes the emission of photoelectrons, for which the stopping potential is 0.5 volt. Here Vs is equal to 0.5 volt with light of wavelength 0.4 micrometer. Okay, so this is 0.4 into 10 to the power minus 6 meter. From a sodium lamp, the stopping potential is 1.5 volt. With this data, the value of H by E is. Okay, so let us write the photoelectric equation. Okay, so Hc divided by lambda is equal to maximum kinetic energy of the electron E into Vs plus work function phi, right? Now Hc divided by E lambda is equal to, Hc divided by E lambda is equal to, here Vs plus phi divided by E, right? Vs plus phi divided by E. Now for first wavelength, here Hc divided by E into lambda is 6 into 10 to the power minus 7 is equal to Vs is 0.5 volt plus 5 divided by E, right? Isn't it? So now I can rewrite this equation as phi by E is equal to Hc divided by E into 6 into 10 to the power minus 7 equal to, sorry, here this will be minus. Okay, this will be minus 0.5. Okay, so now for second equation, that is for second wavelength, here phi by E is equal to, here Hc divided by E into 4 into 10 to the power minus 7 minus 1.5 volt, right? Isn't it? So now from these two equations, here substitute phi by E to this equation. Okay, Hc divided by E into 4 into 10 to the power minus 7, right, minus 1.5 is equal to Hc divided by E into 6 into 10 to the power minus 7 minus 0.5. Okay, so now Hc divided by E, okay, Hc divided by E into 1 by 4 minus 1 divided by 6 into 10 to the power 7, okay, which is equal to 1. Okay, now we need to find h by e value, right? Isn't it? So h divided by e is equal to 1 by 4 minus 1 by 6, right? So what is the value of 1 by 4 minus 1 by 6? Take 1 by 2 as common, 1 by 2 minus 1 by 3, right? So this will be 1 by 6, right? 1 by 2 minus 1 by 3 is 1 by 6. So 1 divided by 12, right? So h by e is equal to 12 divided by c into 10 to the power minus 7, right? C is 3 into 10 to the power 8, right? So 10 to the power 8 into 10 to the power minus 7 is 10 to the power minus 15, right? So h by e is 4 into 10 to the power minus 15 volt second. So the correct option is C. Okay. Okay, thank you. Thank you so much for watching this video. If you love this video, please like and share. Okay. So if you want to watch more such videos, please subscribe. Thank you.